Section 1.6, Properties of Real Numbers. In this section, we're going to take a look at 5 different properties that are exhibited by real numbers. We'll start with the commutative property. Here on page 78 at the bottom, we have a brown box that gives us the commutative properties of addition and multiplication. It says A plus B equals B plus A, and A times B equals B times A. That is, anytime you have an addition or a multiplication, they can be turned around. You get the same answer either way. 2 plus 3, 3 plus 2, same thing. 4 times 5, 5 times 4, same product. The term commutative has to do with commuting, which means what? Moving from one place to another. So the commutative property talks about moving these terms or moving these factors and still getting the same result. The commutative property has to do with the order in which you add or multiply. Notice that subtraction is not commutative. Division as well is not commutative. You cannot change the order in which you subtract or divide and expect to get the same answer. But addition and multiplication, both commutative. On page 79, the brown box middle of the page talks about the associative property. The associative property, if you look closely at that blue box, what's changing from one side to the other in that addition? It's the grouping. In other words, it doesn't matter how you group an addition problem. You'll get the same answer no matter what pair of numbers you add together first. You've got 2 apples and 3 apples and 4 apples. How many apples do you have? Well, you could say I've got 5 plus 4 is 9, or here this is what? 2 plus 7 is 9. It does not matter how you group an addition problem, nor does it matter how you group a multiplication problem. This would be 10 times 10 is 100. This would be 5 times 20 is 100. So addition and multiplication are both associative. Associative means how they're grouped together. Your associates, that's your crew, that's your group. And so associative properties have to do with how we associate or how we group the numbers. Notice that neither subtraction nor division are associative. So there's 2 of our properties out of the way. On page 80, just below the center of the page, we talk about the identity properties. And basically, the identity properties simply say anything plus 0 is itself. Anything times 1 is itself. The identity of that number, in this case we called it A, is unchanged. The identity remains intact when you add 0 or when you multiply by 1. Just below the brown box, it says we call 0 the identity element for addition or the additive identity, and 1 is the identity element for multiplication or the multiplicative identity. We use multiplying by 1 all the time when we're dealing with fractions. If we want to change a fraction to have a different denominator, we multiply the top and bottom by the same number. Let's say we want to turn this into twelfths. I'd multiply the top and bottom by 4. And we have mentioned in class that this works because 4 over 4 is 1. Anything times 1, what? Is itself. And so we're changing the way the fraction looks, but we're not changing its value. And so this is using that identity property of multiplication in order to change the denominator of a fraction without changing the fraction's value. 0, we often hear referred to as nothing. If you add nothing to something, it stays the same. You will often hear me refer to 1 as the multiplicative nothing. 0 is the additive nothing. 1 is the multiplicative nothing, because anything times 1 remains itself. Nothing happened to that factor when you multiplied by 1. Now these are the identity properties, not to be confused with the inverse properties. Here on page 81, the inverse properties. The first one says A plus opposite A is 0. And the second line, A times the reciprocal of A is 1. That is, if you add opposites, like -2 plus 2, they what? They cancel out, and they give you nothing. They give you 0. Or if you multiply reciprocals, look at this as multiply the tops, multiply the bottoms, you get 28 over 28. Or if you cross cancel everything, you get 1 over 1. Either way, you get 1. So when you multiply reciprocals of each other, you get what? The multiplicative nothing. You add opposites, you get the additive identity, which I call the additive nothing. When you multiply reciprocals, you get the multiplicative identity, or what I like to call the multiplicative nothing. Do not confuse these properties with the identity properties. Identity properties leave things alone. Identity property says 6 times 1 is still just 6. That would be identity. The inverse property would look like 6 times its reciprocal gives you 1, the multiplicative nothing. Identity leaves things alone. Inverses cancel. Whether you're adding opposites or multiplying reciprocal, inverses cancel to leave you nothing, the additive nothing or the multiplicative nothing. Inverses cancel, identities leave things alone. They do not change the value of the original number. We have one last property to look at. This is the distributive property we find on page 82 at the bottom. And I'm going to do something similar to what she has here in figure 16. Let's get a figure up here on the board. And what I want to do is count all the little squares, but without actually counting individual squares. I want to know how many little squares, and this isn't an internet IQ test. I'm not looking for the squares that are 2 by 2 or 3 by 3. Let's call these ice cube trays. I want to know, together, these two ice cube trays will make how many ice cubes without counting individual squares. Some of us are going to look at this and say, well, this first one is 4 by 2. There's 8. And this one is 4 by 3. Is 12. 8 and 12 make 20. Some of us, on the other hand, are going to slide these together in our head. And we're going to say this whole thing, if I slide it together, is 4 by 5. And so again, I get 20. So in other words, what we just said, some of us are going to say this is 4 times, and where'd that 5 come from? 2 plus 3? If we slide them together, or if we look at them separately, we had 4 times 2 plus the other one 4 times 3. And if we look from left to right in this equation, what does it appear has happened to the 4? The 4 has been distributed to each of the 2 terms inside the parentheses. Now, for a problem like this, we would not use the distributive property. We'd use order of operations and just say 4 times 5. We're simply illustrating that this will work. This gives me 20. That gives me 20. We'll use this to be able to carry out simplifications that could not otherwise be done. It turns out the distributive property is a very powerful tool in algebra. We'll be using it from this day forward. But consider, if I have 3 times x plus 4, and I ask you to simplify, I'm not going to say evaluate because we're not going to get a number. We'll do more with simplifying in the next section. But consider for now, if I want you to simplify this, I want to do everything I can possibly do and get this boiled down as far as I possibly can. Well, order of operations says you do what's in the parentheses first. Without knowing the value of x, I cannot do what's in the parentheses first. So I would be stuck, except I have this distributive property as one of the tools I can use to algebraically now manipulate this expression. I cannot do the addition in the parentheses first, like the order of operations says, but the distributive property allows me to skirt around that order of operations and lets me go ahead and multiply this 3 by bringing it in, distributing it to each of the 2 terms inside the parentheses. This is typically a mental step. We look at that and we say 3 times x is 3x. 3 times 4 is 12. And that's simplified. The distributive property allowed me to go around the normal order of operations. And that is a very powerful tool. Pay close attention to the examples in this section. And notice here on page 84, bottom of the page, we have a large brown box which summarizes these 5 properties. Let's look at some homework problems. I like number 4. Here on page 85, number 4, it's asking us to tell whether or not these following everyday activities are commutative. That is, can they be done in either order and still get the same result? Number 4, putting on your left sock and putting on your right sock. Can you turn that around and the results still be the same? Yes, those activities are commutative, because you can do that in either order, left first or right first. You still get your socks on. Number 8, getting undressed and taking a shower. Are those activities commutative? Can they be turned around? Can you do them in the other order and still end up with exactly the same result? Not this time. If you turn that one around, take the shower before getting undressed, you've got wet clothes, which is a very different result from getting undressed and then taking a shower. So number 8, no. Those are not commutative. Looking at the problems that we see starting with number 23, I'm just going to make up some similar problems here on the board and give you an idea of what I'll be looking for on a quiz or a test when I ask you what property is illustrated by the following. And so if I say, what property is illustrated by the following? 20 plus 50 equals 50 plus 20. Well, what has changed from one side to the other? It's the order of the addends. Order has changed, so this illustrates the commutative property. All right. If I say 4 plus 0 is 4, what property has been illustrated? Well, we're adding the additive nothing, the additive identity, to a number, and that number remains the same. Its identity remains intact. If I give you a problem, say 2 times 3, quantity times 4, equals 2 times quantity 3 times 4. What has changed from one side to the other? The only thing that has changed is how this multiplication is being grouped. Changing a grouping, that's illustrating the associative property. If I have 2 times the quantity, 8 plus 3, is equal to 2 times 8 plus 2 times 3. What has changed from one side to the other? What has happened? I've taken and I've distributed that 2 to each of the 2 terms in the parentheses. So this is the distributive property. Now be very careful. 1 plus 2 quantity, add 3, is equal to 2 plus 1 plus 3. What has changed from one side to the other? Did the grouping change? The grouping did not change. The only thing that changed is the order of these 2 addends in the parentheses. So the only thing that has happened here, we've commuted those 2 terms with respect to addition. So that's commutative. How about this? 2 times quantity, 8 plus 3, equals 8 plus 3 quantity times 2. What has changed from one side to the other? The order in which the multiplication is done. I've traded places. 2 times this equals this times 2. So that's a commutative property. We changed the order. We did not change grouping. We did not distribute. The only thing that changed is the order. And I may ask you to be more specific. I may say, what property is illustrated? Commutative property of addition on this one. Commutative property of multiplication on this last one. So that's how you're going to handle these problems 23 through 41 in the homework set. Let's have a look at number 44. Now, listen very carefully. In number 43 through 53 on your homework, these are to be done mentally. You are not to write down any steps. The instructions here say find each sum or product. You're not going to have problems like this on a quiz or a test. But this is a good thing to practice here. It's what? 6 little problems? And all she's wanting you to do is take advantage of these properties to be able to do these problems mentally. Now on the board, I am going to write down what I'm thinking. So here's my thought bubble. I'm thinking, you know, if I could get that 49 and a 1 together, that's easy. 199 plus 1, that's easy. So in my head, I'm saying, I'm going to add 1 to the 49, and I'm going to add 1, the other 1, to the 199. And in my head, I'm going to do that pair and do that pair. which will give me 50 plus 200. And again, this is all mental. I'm just showing you on the board what's going through my mind. Total of 250. Again, the idea is to use the properties that we have. So what do? When we swap the position of this 199 and this 1, we use the commutative property. When we put up these parentheses, when we chose what to add in our head, we use the associative property, because we know that addition can be performed in any order and any grouping. Any order because it's commutative, any grouping because it is associative. So that's all that's going on here in these problems. Let's do one more. Let's grab number 54. And again, this is to be done mentally. I certainly wouldn't want to try that in my head, multiplying it out exactly as it's laid out. Do you see what we're going to want to do? You may want to pause the video here and just ponder on that for a minute. Do the work mentally. So I see this 25, and I go, that could be a nice number to work with. And I see these 2's. 2 times 2 is 4 times 25 is 100. So in my head, I am rearranging so there's my commutative property at work, and I'm determined to do these 3 factors first. There's my associative property at work. Since we're doing this mentally and we would not be writing down this step, let's think about this. If I'm multiplying a series of factors and I have an odd number of negatives, my answer will turn out what? An odd number of negatives will give me a negative answer. If there happened to be an even number of negatives, what? Every 2 negatives would make a positive. So that if there are an even number of negatives, my answer would turn out positive. So in my head, I'm going, I see an odd number of negatives. My answer will be negative in this multiplication problem. I see 2 times 2 is 4 times 25 is 100. And then 100 times 67, well, 6,700. And again, it is negative. So on this bank of problems, on the problems 43 to 53 in your homework, do those 6 problems in your head. Certainly if you want to write down the original problem on your paper, that's fine, but then I don't want anything else but that final answer. We're doing a similar kind of thing as we start the problems here with number 55. I'm going to grab 56. Let's work 56 together. It says simplify each expression, and bear in mind that our focus in this section are these properties of real numbers. So whether on paper or in my head, I want to rearrange these. I would probably do that just as a mental step, because this one's not too tough once we take a look at it. And I would rearrange them. Now wait a minute. Subtraction is not commutative, is it? You can't move subtraction around. Well, what do we know about subtraction? What is the definition of subtraction? We're just adding the opposite. So if we think of this as plus a negative 9r, I can now use the commutative property with respect to addition. In other words, I am fine to move these terms around so long as I keep negatives with their terms. Signs belong to their terms. So whether I write plus a negative, or I'm just thinking that I know subtraction just means to add the opposite, when I go to juggle these around, this negative has to remain with that term. So our 9r up front I'm going to move our negative 9r into second position, swap him with that 12. And again, that's probably a mental step. And then what happens? 9r minus r, or 9r plus negative r. Those are inverses of each other. They will subtract out to leave me nothing, the additive nothing. And 0 plus whatever is just whatever. Again, this is likely all mental steps. If you need to write some of it down, do it. You don't want to miss a problem just because you wanted to skip steps. But looking at this, can you see? 9r minus 9r leaves nothing, the additive nothing, and so we're left with 12 plus 1 is 13. What I've shown here in the thought bubble is just that actual process of using these properties of real numbers. Let's look at number 60. In number 60, we have all multiplication. And what can you spot right away? I see some multiplicative inverses, some reciprocals. I know that they will cancel and leave 1, the multiplicative nothing. So what's going on in my head is I'm saying, I know that multiplication is commutative. I can put these in any order that I want. I know that multiplication is associative. I can multiply any 2 of these together that I want and still get the same answer. So what if I group those together? Again, this is going on in my head. I just look up here and I go, oh, I'm multiplying multiplicative inverses. They cancel. They multiply to give me 1. And 1 times the rest is just the rest. Probably don't need to write down any steps for this. This one's not too tough to just look at and go, those will cancel. They'll leave 1, the multiplicative nothing. So the only thing that survives here is that decimal in the middle. Number 62. As we look at this, we see we're adding. We have 3 different terms, the W, the negative W, and this product at the end. And I can group those however I want. And so I'm going to choose to add the first 2 together first. That's my associative property of addition. W plus negative W, those are opposites, they're additive inverses, so they cancel. They subtract out to nothing, 0. And plus 1/4 of 4. 1/4 times 4, those are reciprocals, multiplicative inverses. And so they will cancel, but we're multiplying. So when I say they cancel and leave nothing, what nothing am I talking about? The multiplicative nothing, which is 1. And then finally, 0 plus 1 is 1, nothing to it. Here at the bottom of this page, we're going to practice using the distributive property to simplify expressions. Number 70, just a nice little warm-up problem. The order of operations would have me do what's in parentheses first, but I don't know the value of W, so I can't do what's in parentheses first. Can I go ahead and perform the multiplication out front without adding in the parentheses? I can if I distribute. I can use my distributive property to distribute this 5 over this addition. 5 times W, 5W. 5 times 4, plus 20. Number 78. One instruction you're going to hear over and over this semester. Watch your signs. Watch your signs. A lot of mistakes that we make have to do with sign errors. So pay very close attention as we distribute this -9. Distributing is defined over addition. Well, we know that subtraction is just addition in disguise. This means plus a -4. So as we distribute this -9 over what we're going to consider to be a little addition, plus a -4, -9 times g is -9g, and then what? -9 times -4 is going to give me plus a positive 36. -9 times -4 gave me plus 36. Watch your signs. Number 86. If we look at that closely, it turns out not to be as bad as we may have originally thought. That 5 is going to cross cancel nicely as we distribute in. In fact, I would say that most of us can do this in a single step. As we distribute this -2/5 to each of the two terms inside the parentheses, we're going to say a negative times a positive is negative. 2/5 times 10. I'm going to cross cancel on the fly. 10 divided by 5 is 2, times 2 is 4. Here's what I just did. I said 2/5 times 10. I know that the 10 belongs to the numerator. I cross canceled. 5 goes into 10 twice. That gives me 4 over 1 is 4. Now how did I say it over here? I said 10 divided by 5 is 2, times 2 is 4. 10 divided by 5 is 2, times 2 is 4. We already knew it was negative. We've multiplied our numbers, and that's times b. Watch your signs. Negative times a positive is negative, so minus. 2/5 times 20. If you need to come over to the side and do that, do it. But I would like you to get used to this idea of cross-canceling on the fly. 20 divided by 5 is 4, times 2 is 8. 20 divided by 5, because I know the 20 belongs to a numerator in this multiplication that I'm doing. So 20 divided by 5 is 4, times 2 is 8, and times that a. So that one turned out not to be too bad. The distributive property will work over more than two terms. Consider number 88. Here's another place where I will caution you on handwriting. We mentioned that in class, but U's and V's. I've had students that have given me fits trying to figure out what they've written. U's should be round on the bottom. I give mine a tail so it's very clear that it's not a V. V's should be pointing on the bottom. Just make sure I can read. It is your responsibility to effectively communicate your steps and your answers to me. Give me no room to misinterpret what you've written. We'll distribute this too. There are 3 terms inside the parentheses. And so we will distribute to each of these 3 terms. 2 times 5u, 2 times 5 is 10, so that's 10u, minus 2 times 3v, 6v, and plus 14w. Distributing that 2 to each of those 3 terms. Number 92. 92 is also a distributing problem once we recognize what we're looking at. Negative, the quantity. 9x plus 12y. I want to simplify. I want to do everything I can do, which includes trying to drop those parentheses. I can do that when I recognize that there's a multiplicative nothing sitting right here. This negative out front really represents what? A negative 1. On a quiz or a test, I'm not going to write that 1, but we know that that's what it means. So now as we distribute this negative 1 to each of the two terms inside, negative 1 times positive 9x, negative 9x. The 1 doesn't do anything. Well, it's the multiplicative nothing. And so all that multiplying by negative 1 does is change the sign on the term. It was 9x, now it's minus 9x. Same deal here. Distribute this negative 1. Negative 1 times positive 12y is minus 12y. I generally will not write that 1, and you will usually hear me refer to this as distribute the negative. So let's look at another one. Number 96. We have three terms inside the parentheses. We're going to distribute this negative, which we know is a negative 1. I'm going to say let's distribute this negative to each of these three terms. The effect is to do what? Change the sign on every term. So you distribute a negative to this minus z, you get a positive z. Distributing the negative to the middle term gives me minus 5w. And to the last term, plus 9y. Distributing a negative simply has the effect of changing the sign on each term in the parentheses. As you go to do your homework, remember, problems 43 to 53, I want you to do those mentally. And pay very close attention to what's going on when they ask you to decide what's being illustrated. Commutative, associative, identity, inverse, or distributive. And remember how to tell that identity and that inverse apart. Identity, something plus 0 is itself, something times 1 is itself. Inverses, you add two opposites, you get 0, they cancel. You multiply two reciprocals, you get 1, they cancel. So be sure that you can distinguish between especially identity and inverse properties. All right, you should be able to get started on that homework now.